So this is just going to be the worked solutions where I talk through them to the independent algebraic tree diagrams that you did on Wednesday the 24th. So, question number 1. There's 2 bags. Bag A has 12 discs. 5 that are red, 6 that are blue, 1 that are white. And then bag B has 25 discs, where n of them are red, and the rest are blue. The total is 25. So if n of them are red, and 25 in total, well there must be 25 minus n lots of blue ones. The total take away how many red ones there are. That's what's left, so that makes them blue. And if you add them 2 together, you're going to get 25, so that's how you know it's kind of on the right lines. You're going to draw your tree diagram. A is going to have 3 branches because we're going to have red, blue and white, and then you're going to have 2 branches off each of these, 1 for red and 1 for blue. Let's have a go at just kind of getting some of these probabilities. So red is going to be 5 out of 12. Blue is going to be 6 out of 12. I'm just going to leave them as all out of 12 for now. I'm not going to simplify them. And white is going to be 1 out of 12. So let's fill that in. And then these ones, well, this is a little bit harder. Red, in this case, is going to be how many red ones there are out of the total. And blue is going to be how many blue ones there are out of the total. Oh, sorry, that's not an n, that's 25. So it looks a bit weird, but when we know what n is, it's basically just a number. So I'm going to fill that in. N over 25, n over 25, n over 25, and then squeeze this in. That'll be 25 minus n over 25. And I'm just going to put that there because they're going to be the same. They're all going to be what this is here. I'd draw this bigger if I wasn't doing it on a screen and trying to fit it all on here. I'd use a full piece of paper for this. So James randomly takes one from A and then he takes one from B. Given that the probability that James and Lucy both take red discs is 2 out of 5. So that means red, red, this path here, equals to 2 out of 15. And if we were to calculate this, it would be 5 out of 12 times by n over 25. That's what we would do if these were both just numbers. We would multiply them. So we have 5n over, well, I'm going to have to do this decent calculation, so I'm going to get my calculator out. 12 times by 25 is 300. And that equals to 2 over 15. So I'm going to times over by 300 times over by 15, so a bit of cross multiplying. You can do this in more steps if you want to. And then I'm going to divide, so n equals to 8. Let's check that that's actually what they wanted. But hence find the value of n. Okay. That's all they wanted. They just wanted us to find n. So that means there are 8 red counters in there, so there must be 17 blue counters in that bag. Question 2. This is a follow-on from the previous question, and they've said given that n equals 8, that's what we've just found, so we know that we must have been correct. So this would have been a part A and B question. Calculate the probability that James and Lucy take discs of different colours. I'm actually going to go up here again and go into a red. So different colours. That's either going to be red, blue, or blue, red, or white, red, and white, blue. So we've got these 4 to calculate. If I actually capture this and pull it down to here, I can have it nice and big. So there we go. The probability of red is actually going to be, what did we find it as, 8 over 25, and the probability of blue is actually going to be 17 over 25. So we can continue that on all of these branches. So this probability is going to be 5/12 times by 17 over 25. This one is going to be 6/12 times by what red would be, which is 8 over 25. This is going to be 1/12 times by what red would be, which is 8 over 25. And this is going to be 1/12 times by what blue would be, so 17 over 25. We've got the task of calculating them four, and then we're going to add them together, and that will be our probability. We could also do the two paths I haven't ticked and take them away from one, but that's completely up to you which way you do it. I've already started this way, I'm going to carry on. So the reason I never simplify my fractions in the tree is because I know these are all going to be out of 300, so it just saves me a job. And then 6 times 8. So a job of adding all these together. Just add the top numbers. Oops, I've times them. So I'm going to go up to here for that. That's 158 out of 300. And when I simplify that, you don't particularly need to. I'm going to get 79 out of 150, or as a decimal it's going to be like 0.53, 53%. Okay, question 3. Adam has a bag of 6 lemon sweets and n strawberry sweets. So lemon is 6, strawberry is n, so then the total must be 6 plus n. Adam takes a sweet from the bag, sticks it back. I don't know why he wouldn't eat it, what's the point of picking out a sweet? And then he takes out another sweet. The probability that Adam takes 2 lemon sweets is a 9th. Write an equation in the form. So when it's something like this, it looks a bit weird and scary. That is basically just saying answer the question like you would normally, and you're going to turn out with something like this. So I wouldn't focus too much on this line. That's if you do the right work, and you're just going to end up with that, and then you'll realise, okay, that's now I'm finished. So I'm not even going to take notice of that. I'm just going to answer the question. So lemon, strawberry, lemon, strawberry, lemon, strawberry. If I was being really clever, I would have actually only drawn these top 2 branches because we don't care about anything else. We only want 2 lemons. So that will be 6 over the total, 6 plus n, and 6 over the total, 6 plus n. I'm not going to fill in the rest because I don't need it. So I know that 6 over 6 plus n times by 6 over 6 plus n equals to a 9th. And then I just need to go ahead and do this algebra. So that will be 36 plus 12n plus n squared. You can see we're kind of getting there. Equals a 9th. So I'm going to times this side by 9. So 36 times by 9 gives me 324. And then I'm going to times all of this by 1, which will just give me n squared plus 12n plus 36. Then I'm going to take 324 from both sides. So 36, take away 324, gives me minus 288. So in fact we are done. We could be asked to solve this, if we can factorise it, etc. But that is as much as we actually need to do, because we've got it in the form that they might ask us to say what B is and what C is. So I'd say, well, B equals to 12 and C equals to minus 288, because there's B and C there. But you can see I didn't even take notice of that line, I just fell on it, and then I realised, okay, now I'm done. Question 4, another one. So again, It's saying prove that. That's basically just saying do all the working as normal, and you're going to end up with something that says 2n squared plus something n plus something equals 0. And then that's when you stop. That's your answer. So, a bag contains n tennis balls. So the total is n plus 7. The amount that are yellow are n, and the amount that are white are 7. He'll take a random ball from the bag, look at its colour and put it back. After John's put the ball back, Mary will then come out. So given that the probability that John and Mary take different colour balls is 4/9, so we're going to have John and we're going to have Mary. So we're going to have yellow, white, yellow, white, yellow, white. Probability of yellow equals to n over n plus 7, and the probability of white equals to 7 over n plus 7, 7 over the total. So I'm actually just going to fill in the branches I want. I just want this branch and this branch. That is when they're different colours. And then this final one. So I'm going to do n over n plus 7 times by 7 over n plus 7, and I'm also going to do 7 over n plus 7 times by n over n plus. These are the same thing, aren't they? So I'm actually just going to do this and then times it by 2, because that would be the same. So 7n over n squared plus 14n plus 49. You can do your expanding double brackets on the bottom if you can't do it that fast. And again, if I do the same for this, it's going to be exactly the same. So if I add these together, that's going to get me 14n over n squared plus 14n plus 49, as we've got common denominator, so we just add the top. And the probability of that is going to be 4/9. So this equals to 4/9. So then I want to cross multiply, so times 9 by 14n and times all of this by 4. So 9 times by 14 so 126n, and that'll be 4n squared plus 4 times 14, 56n, plus 4 times 59, 236. I then want to say 0 equals to 4n, so taking 126n from both sides. This is horrible algebra, but sometimes you just got to do it. And that'll be minus 70n plus 236. And we want it in the form 2n squared, so we are just going to divide by 2. So 0 equals to 2n squared minus 35n plus 118. And we're done. So in this case, A would be minus 35, and B would be 108, C would be 118. Oh no, A and B, yeah. So B would be 118. Question 5. Red is n. There's 2 more blue counters than red counters, so blue is going to be n plus 2. The number of white counters is equal to the total number of these, so add them together, 2n plus 2. And then the total in this bag would be 4n plus 4. They play a game. They take a counter from the bag at random, they'll record it and put it back. Probability that Bob's counter is red and Anne's counter is not red is 14/81. Prove this. So basically, like the last 2 questions, we just want to do the work as normal and end up with something that looks like this. And then we'll state what A, B and C are. So, drawing my tree diagram for this. I'm going to be a bit smart about this, and I'm only going to draw the paths I want. So I've got Bob and Anne. I'm actually only going to draw the red path. This path doesn't concern me. I'll stick it there, but I'm not going to do anything else with it. Because we've got 3, haven't we? We'd have red, blue and white, but I don't need any of that. And then I'm just going to focus on this one. So, we've got red, blue and white. Probability of red is n over the total. And I only care about the probability of blue and white because they are the paths I care about. Red and then not red. Red, not red. So red, blue or red, white. Probability of blue is n plus 2 over 4n plus 4. And then this is going to be 2n plus 2 over 4n plus 4. So if I go ahead and do these calculations, so n over 4n plus 4 times by n plus 2 over 4n plus 4, that's going to be equal to n squared plus 2n over 16n squared plus something plus 16, so that'll be 32n. You can take that slower if you want to. And then this one is going to be n over 4n plus 4 times by 2n plus 2 over 4n plus 4. And when I go to calculate that, the denominator will be the same. So it's all going to be over that 16n squared plus 32n plus 16. And this is going to be 2n squared plus 2n. So what I need to do is take this, and add them together. So when I do that, I'll get 3n squared plus 4n all over this big quadratic. And that is going to be equal to 14 over 81. And this is the beautiful thing of expanding all of this. We could have been a lot smarter with this. We actually know we could actually say, well, this is this could be factorized to 2 lots of, sorry, I'll redo that. This bottom bit could be factorized to 2 lots of 2n plus 2. And then they could cancel out, so this fraction is actually just a half. I've made it a lot more work for myself by not doing that. That's probably something that we should actually look out for, if you ever can. But I've already started this, so we're going to go ahead, and I'm quite comfortable with my algebra. So I don't worry too much about having to cancel down. So I'm going to times that by that, and times this by this. Cross multiplying is our best friend in this case. So 3 times 81 is going to be 243n squared. 4 times 81 is 324n, and that's going to be equal to 14 times 16, which is 224 n squared. 32 times 14, which is this, and then 16 times 14, which is 224. Let's check what we're wanting to do again. We're wanting to get it in a quadratic equals 0 form, so I'm going to make this equal 0. So I'm kind of going to take all of this stuff over there. So 243, take away 224, that equals 219n squared, so I've dealt with these two. And then I'm going to do 324, take away 448. That gets me minus 124n. And then I'm going to take away the 224. Can I divide these all by 19? No. So, in fact, just going to have to leave it like that. And that's the best we can do. they've let it to be an plus bn plus c, so we're completely fine for these to be any numbers we want. And then the final one, which was the stinker question. It's because we've got to set up two things, so it's a bit like a simultaneous equation question at the same time. So there's only red counters, yellow counters and blue counters in a bag. Takes at random a counter, puts the counter back in the bag. Lethner takes a random counter from the bag, she puts it there. So the probability that both counters are red, or both counters are yellow, so some probability of red red and then probability of yellow yellow, equals to 13 over 36. And the probability that the first counter is red and then the second counter is not red equals to a quarter. I'm going to model this a little bit, and I'm going to say, well, let's let the probability of red equal x and the probability of yellow equal y. Then I can say, well, the probability of what's my other colour here? Blue. It's going to be 1 take away x, take away y, because these three need to add up to 1, don't they? So we can go ahead and start drawing our tree now. So we've got red, yellow, blue. The probability of this is x, probability of this is y, and the probability is 1 minus x minus y. I don't think we ever need to use this, so it's not a problem. We actually don't care about any of these lines, do we? We only care about what's going on up here, because we're either asking if it's red first or red first, so we only care about this. So red, yellow, blue. Probabilities stay the same because they replace it. So here we go. Probability of it being red, red, or we do actually care about yellow, yellow, don't we? But that's just going to be another, yellow is going to be another y. I'll actually rub this out, make it a little bit neater. So we do care about that yellow path. So these are the paths we care about to start with, red, red, and yellow, yellow. So red, red, plus the probability of yellow, yellow, equals to 13 over 36. So x times x plus y times y equals 13 over 36. I've done x times x and y times y. I'm just going to keep that in the back burner for now, and I'm going to label it equation 1. I'm going to deal with this next one now. So the probability that the first counter is red and the second counter is not red. So I need to do these two paths. Well, we know if we do red times yellow, red times blue, that is going to give me x. And if I count kind of, I mean, we could just do, x times y and then x times 1 minus x minus y. It could get messy, and I don't particularly want y's in there because I want to be able to solve this. I just want to have x's. So if I revise my tree diagram, and I am just going to have it as red and not red, because that's all this second part is asking. It's only asking about red or not red, so we don't actually care if it's yellow or blue. We just want red or not red. So red or not red. So the probability of red is x. The probability of not red is 1 minus x, and you can actually get that by doing 1 minus x minus y plus y. That'll just get you 1 minus x. So we care about this, and they've told us that that probability is a quarter, and that equals to x times by 1 minus x. So if I expand that bracket, It's x minus x squared. And you may, from here we probably need a different skill to kind of rearrange it and factorize it and solve it, but we might just be able to spot that if we have x equals to a half take away a half squared, so that's a half take away a quarter, well that does equal a quarter, so x equals to a half. That might be something that we can just spot, so that was kind of the added little challenge in there. I'll rewrite that on. So now we know x is a quarter. We've got that from our second one. We're going to substitute it back into equation 1. So again, it's a bit like simultaneous equations, isn't it? You solve one and you use it to solve the other. So a half squared plus y squared equals to 13 over 36. So that's a quarter plus y squared equals 13 over 36. I'm going to take the quarter away. So 13 over 36. Take away a quarter. It's very nicely a ninth. So then when we square root that, y is going to be a third. So we've got x as a half, y is a third. Let's actually see what the question's asking us again. Find the probability of Seb taking a yellow counter. Well, we've said that the probability of yellow is y, and we've found that y is a third. So in fact, the probability of a yellow counter is a third. And I know what you're thinking. There's 3 things, couldn't we have just divided by 3? No, this is just a coincidence. I'm sure if we found, as we found x, it's not a third, is it? So blue would be 1, take away a third, take away a half. Just a coincidence that this is a third, and there's 3 options. Okay, hopefully that was helpful to any sort of mistakes you made in there. That was a really tough question, and this was horrible algebra, which is tough in itself. Alright, cheers.